Hello, you're welcome. All right, now the topic is kinematics. All right, now what is kinematics? Now, kinematics is actually the area of physics that actually studies motion. All right, area of physics that studies motion without, regarding the cause of the motion. So, I can simply say that kinematics is actually motion, without considering the force, because we generally know that it is force that actually causes motion, right? A body is said to be at rest, okay? It can only change its position of being at rest if only a force is being applied to it, according to Newton's second law, right? So according to Newton's second law, we know that change in momentum of a body is dependent on the force applied to it. Okay, so in this tutorial, we're only concerned with the motion, okay, and of course parameters that are associated with motion. Now, question is, what is motion, right? Now, motion is actually defined as the change in position. Change in position of an object with time. Change in position of an object with time. Let's say an object is located at a point x1, okay, with respect to a particular reference point. Let me say with respect to the origin of a graph. All right, then after the interval of time t, it now changes its position to x2, right? So we can simply say that this object will undergo what? Motion. Now, in study of motion, there are parameters we need to actually learn. Now, the whole idea of this tutorial is to give you the basic foundation, all right, and to make you understand the principle behind linear motion of an object, motion under gravity, and of course a projectile motion. So, and I'm gonna start from the simplest term, okay, then after which we'll now take it to the complex terms, where we are going to be talking about the graph, derivative, and of course vectors, right? So that is how we flow, okay. Then at the end of the day, we'll now solve examination question. All right, so now we are going to be looking at basic terms that is used in describing motion, okay, and those basic terms include speed, velocity, and acceleration. All right, so I'm gonna start with speed. Now, speed and velocity, they are similar. Of course, I'll tell you they are different, so I will be using v, all right, to describe it. Okay, so now, what is the speed of an object that is actually under motion, right? Of course, in a layman term, you can say that the speed is actually describing how fast an object is, okay? But physics describes speed as the change in distance. Change in distance with time, okay? Change in distance with time. And of course, the SI unit is the SI unit of distance is meter, and the SI unit of time is seconds. All right, so speed is meter per second. So how the object changes distance with time? So if an object changes a longer distance in a shorter time, then it's said to have a a greater speed than the object that changes a distance, okay, the same distance but in a longer time. Of course, I believe you know how you understand what I mean by that, right? So now we're gonna look at velocity. All right, now we say that for velocity, okay, is described as the change in displacement of an object with respect to time, with time. And of course, displacement, if we should go by SI unit, is still in meters and time is still in seconds. So you discover that both velocity and speed have the same SI unit, okay, which is meter per seconds. Now the question now becomes, what is the difference? All right. Now for displacement being uh being for velocity, okay, being, that is how the distance of velocity is being measured. We measure the distance of velocity in displacement. All right. Displacement is different from distance in that displacement is a vector quantity. In fact, displacement is a distance in a specified direction, which of course you are told that vector quantities, all right, are quantities that has magnitude and direction, all right, while scalar quantity has only magnitude. Now for me to illustrate this, okay, let's say an object originally was at S1, it moves to S2, then now return back to S1 where it's coming from. All right, by distance I will simply say that, okay, the distance is just double, okay, the displacement, the difference between x1 minus x1 minus s2 minus s1 rather, right? So it did that s2 minus s1 s2 minus s1 two times. So I'm measuring what it did, what it covered by moving, okay, forth and back. All right. But for displacement, I will simply say that displacement is zero. Well, at the end of the day, there is no movement because this object still returns back to where it's coming from. One is positive, all right? Then in the same venue, come back negative. So positive and negative. So in displacement, we'll consider the direction. And at the end of the day, you discover that, okay, most times, even though you might have a distance, but the displacement might be saying it is zero. Why? Because after considering the direction of the distance, all right, you can simply say that the displacement of that object at the position where it is zero. Okay, well, that will make more sense as you you go through the tutorial on vectors. All right, but let's still continue with our basic terms. All right, and we are going to be looking at the next important term, which is acceleration. All right, now acceleration is actually defined as the change in velocity. The change in velocity with respect to time. With respect to time. So, which already we know that velocity is measured in meter per seconds, then divided by time again, another second. So seconds multiplied by seconds. So the SI unit of acceleration is meter per second square. Meter per second square. So please take note of that. So, and the object is said to be accelerating when its velocity is actually changing. All right. The velocity, when the velocity of an object is actually increasing in the positive direction, we say that that object is accelerated. All right. As you measure the velocity with time, it is increasing. But an object is said to be decelerated, alright, when its velocity is reducing with time. We call that deceleration, okay? Please pardon my spelling if it's wrong. Okay, so which simply means that if a car is slowing down, especially when a car actually gets to a point where you need to stop, all right? If it is already in a high speed, let's say a very high speed, right? The next thing it does is that it will start reducing, it will apply the brake to reduce the speed before it finally comes to a stop. So this reduction in speed is what is known as deceleration. Okay, I hope that is well understood. All right, so now we are going to go into the major business of this tutorial. What is the whole what's the whole idea of this tutorial? We're going to look at how, okay, to evaluate questions, okay, that deals with motion, right? Because basically when it has to do with motion, you in the examination you will be asked to evaluate or to calculate. Is basically question on the calculation, right? And when it has to do with motion, right, if you are being asked to evaluate those parameters, speed or velocity, right, and of course you have this acceleration, also part of the parameters we consider in motion, all right. We also have distance or displacement, we have time, all right. Now all these parameters is actually connected or is related in an equation known as equation of motion. So most times if you are being asked to solve questions, okay, on motion, you always have to reference to the equation of motion, okay? You always reference to the equation of motion, it will help you. Now when we are considering the equation of motion, we are going to look at, okay, if that motion is actually a linear motion. If it is a linear motion, we say that yes, all right, it's a motion in a straight line, that we consider the motion in a straight line, okay. Then we can also ask ourselves, is it a motion that is under gravity? All right, so if it's a motion under gravity, then it simply means that it is either moving upward or downward under the influence of gravity. Or we ask ourselves, is this motion a form of a projectile? All right, so the equation, the way we use this equation depend on the motion. Linear, okay, motion is under gravity or is a projectile, still under gravity, right? So we're going to look at the very first one, which of course is linear motion. So we are going to be looking at the equation. Equation of linear motion. All right, so I would have loved to prove this equation, perhaps I will, All right, but let me state the three equation. All right, now sometimes most book, all right, that you consult will give you four equations, but those four equations can also be summarized into three equations. All right, the very first equation is given as v equal to u plus 80. The second equation is given as x equal to ut plus half 80 squared. The third equation is given as v squared equal to u squared plus 2ax. Alright, I will probably prove the origin of this equation, but before that, every equation has parameters, okay, that the equation is actually made up of, and we need to know these parameters so that when we are solving the question, you will not be confused about the parameters. All right, so for the v, we know that the v represents the final velocity of an object. No object actually starts with the final speed. Please, in as much as we are considering motion, we are not looking at vectors or probably directions. So speed and velocity will be the same thing for now, right? Please take note of that, right? So an object doesn't just start moving at the highest speed or velocity, right? It starts slowly. So I'll use v to represent the final velocity, then u represent the initial velocity or speed. All right, then of course a represents acceleration. Okay, what then do we have? We have x. Please take note, we use s to represent the distance travel. Then the t, all right, we use t to represent the time. Okay, so with what we have, right, these are the parameters that you see in this equation. Now the question is, how do we apply this equation? All right, application. That this equation represents, all right, it's an equation that describes the motion of an object in a linear, okay, in a linear direction, a straight line, right? That's one of the things that you should know whenever you are using this equation. It is very simple, all right? That anytime the question you are solving actually says that that object starts from rest, all right, you should take note that for rest, the initial velocity of an object from rest is always equal to 0. So you don't need to ask what the initial velocity is, all right? Now, when the object is already moving, I want to come to rest, okay, to rest. It's already in the final speed, is what it wants to come to rest. The final velocity of this object, is equal to 0. And at that point, one thing you should know that that object must decelerate, all right? All right, decelerate means that the speed must reduce, okay, to the point where the speed becomes 0. So the object must decelerate before it actually comes to rest. And of course, you know that deceleration is always minus acceleration, negative acceleration, all right? So please take note of that. All right, so now let's look at example. I will dictate the question, okay? So you just write it down, okay? So as I dictate the question, I will write the parameters of the question. And the place for you to be able to solve physics question very well, okay, always form the habit of writing down the parameters of your question, all right, before you start solving. The reason being that in the case of equation of linear motion, we have three equations here, and you're not using these three at once, okay? You're gonna use just one equation to solve, okay, a particular task. So what determines the equation that you're going to choose depend on the parameters of the question, all right? For example, the question goes like this: a car starts from rest, all right? Start from rest and move uniformly, right? With a speed, excuse me, a speed of 20 meters per second for 2 seconds. All right. So the question is evaluate a part of the question, the acceleration of the object. Then B, evaluate distance covered within that time. All right, so solution. Now, if I need to solve this, I should consider the fact that if I read the question, said the car start from rest, I will have to write down my parameters. From rest, I will write that u is equal to 0, comma, I go forward, then I move. So from rest, it starts with 0, then it does enters into its final velocity. So it moves with the final velocity of 20 meters per second. All right. Then it actually does that for 2 seconds. So the very first question we are asked to evaluate is its acceleration. Question mark. So these are the parameters of the question. And if you look at these parameters, okay, these are 4 parameters. Now you now ask yourself, which of this equation of linear motion captures these 4 parameters? All right. Now you discover that for me to find the A, I have V, U, A, and T. So the very first equation captures this. So that is what I'm going to use. So V is equal to U plus 80. All right. So let's start putting our values. V is 20. I put it there. Equal to U, which is 0. Then plus A, that's what I'm looking for. Multiplied by T, which of course is 2 seconds. So if I, excuse me, if I multiply 2 by A, I have 2A, right? Equal to 20. So A now is going to be equal to 20 divided by 2, which is 10 meter per second squared. That's the SI unit. And always, please make sure that after you must have solved your question, right, you have to put the SI unit of that particular parameter you just evaluated. It's really very important. So I hope that is well understood. I will still bring more questions because that is the whole idea, to teach you how to solve questions. All right. So let's look at another example. A car moving with a speed of 20 meters per second was brought to rest after traveling a distance of 100 meter, evaluate its deceleration. Okay, so solution. Now the question shouldn't give you a problem because you just gonna read the question and write down the parameters, right? So a cat moving with a speed of 20 meter per second. So this car initial speed is 20 meter per second, right? Comma. I was brought to rest. Remember what I told you about coming to rest, right? When an object comes to rest, the final velocity is equal to 0. After it traveled x distance of 100 meter. So now the question is for us to find the deceleration, which of course is the same as the opposite acceleration, all right? So how do we achieve this? All right, look at this u, v, x, and a, which equation actually captures this three. That's the third equation. So we have v square equal to u square plus 2ax. Okay, how do we flow? Now we have that v is equal to 0 square, u is equal to 20 square, then plus 2 times the acceleration, which I need to find, that's what I'm looking for, then times 100. So this is gonna be 0, this is gonna be 20 square is 400. Now since this acceleration is deceleration, right, then definitely this plus will turn to minus because the deceleration is negative acceleration, right? So this plus will turn to minus. That's going to be because this is minus, a minus into plus is minus, right? That's going to be minus 2 times 100. That's 200. All right, so I take this to the other side of the equation. It becomes 200a equal to 400. So a now is going to be equal to 400 divided by 200. So which is 2 meter per second square. 2 meter per second square. I hope that is well understood, right? So the whole idea is this: you look at the question, read it, write down the parameters, and of course choose the equation of motion that will help you solve the question. All right, we're still gonna look at more questions still on linear motion, but let's talk about the other part of equation of motion, right? So we are going to look at extend it to the equation of motion under gravity. So we're looking at motion under gravity. Okay. Now under this, we are going to look at a situation where this object is going upward. Okay. Look at an upward projection. Then we look at the situation where the object is coming downward, which leads to what is known as free fall. Free fall from a particular height. Now, looking at this, we say that this is motion under gravity, all right? And we know that there is what is known as gravitational force. Every object that is actually thrown up, all right, as that object actually reaches to a particular height, it will start coming down to where it's coming to the ground level, which simply means that there seems to be a force that pulls an object downwards, all right? And we say that is the force of gravitational force. The gravitational force. Now, according to the experiment of Isaac Newton, all right, it says that every object, irrespective of their masses, all right, let's say one with a smaller mass and one with a bigger mass, all right, will always have one acceleration, known as acceleration due to gravity, which he actually expressed with the symbol G, all right. I said the acceleration due to gravity is always constant. In as much as we neglect air resistance on this object, this is a rigid object, there is no air resistance. Say the acceleration due to gravity of the object, whether it's the small object, the small mass, or the big mass, all right, they will have the same acceleration due to gravity, which, of course, after his experiment, he approximated it to be 10 meters per second square. So whenever we are dealing with motion under gravity, we know that G is always constant. You can't change the value, right? And this, consequently, if you have these two objects being released at the same height, right? Let's say they are the same height. Okay, whether this mass is bigger than this or not, if you allow them to fall, to have a free fall, both of them will reach the ground, all right, at the same time. Why? Because the acceleration due to gravity is the same, irrespective of the masses. All right, so please take note of that. So whenever we are dealing with motion under gravity, we always consider G, which is acceleration due to gravity. All right, so please take note of this. So there are two ways of which we gotta consider motion under gravity. We are looking at upward projection, where you throw an object up, all right, then later it will still come down, or where you actually stay in a height, all right, you release an object and it falls down, all right. So all of them will actually comes to our equation. We are going to express everything in equation of motion under gravity. All right, so the equation of motion under gravity is still gonna be similar with the equation of motion of linear motion, okay, or equation of motion in a straight line, horizontally, without the influence of gravity. But there's gonna be slight change. Remember, okay, previously we had that V is equal to U plus AT, but here the very first equation is gonna be V is equal to U plus or minus. In place of A, I use G to replace it, right? For number 2, we have that S is equal to UT plus half AT squared, but I'm not gonna use S, I'm gonna use H. All right, showing that we are dealing with height now. So equal to UT. Then in place of this plus, there's going to be plus or minus. I'll tell you why the plus or minus, when we are to use plus and when we are to use minus. So plus or minus half GT square. Are we good? Then number 3, the last equation, which of course is V square, right, equal to U square. Then I'm still going to have plus or minus, then 2GH. Alright, so you see the whole of this is still similar to the equation we listed before, but the difference is that in terms of the horizontal Linear acceleration, we replace it with the acceleration due to gravity. All right. And of course, in terms of linear distance, we replace it with height. So please take note. And the question is, when do we use plus? All right. We use plus or minus depending on the direction of the motion. All right. When an object is going upward, it's going against gravity. Upward is always against gravity. So because of that, acceleration, the object will be decelerated, right? So acceleration due to gravity will be minus g, and that is when you use minus in this question, when there's upward motion, all right? But when it is on a free fall downward, all right, when it is downward, then definitely it is going for gravity. Gravity is always directed downward. So that is when g becomes positive g. And this equation would thought to be what? Positive. I hope you understand. So let's start with simple examples. Simple example. A ball is thrown vertically upward. With a velocity of 4 meters per second. So the question now becomes, evaluate a part of the question, time to reach maximum height. All right. B part of the question, time of flight. Then the C will have the maximum height. Attained. All right, so before we solve this question, there are certain things we should actually know, all right, in application. When an object is moving upward, already it's moving against gravity, all right? For upward, we know that the acceleration due to gravity reduces, all right? And of course, that is why the velocity will reduce, right? So it will get to a point where it will not go up again. That point is actually maximum height. So please take note of this. At maximum height, the final velocity of that object is always equal to 0. Alright? At maximum height, the final velocity is always equal to 0. If an object is actually coming downward, the motion is starting from a point where it was projected. let's say from top of a building, it is being dropped, right? For downward projection, right, when the object is coming downward from a particular height, the initial velocity at the point of projection is equal to 0. So please take note of this important information for upward and downward. Okay, in as much as motion under gravity is concerned. So now let's go straight to our solution. So you can actually write this down. So you know what we normally do? We write our parameters, okay? So we say a ball is thrown vertically upward with a velocity. That means the initial velocity of the ball is 4 meters per second. And you can see that is the only information that was given in this question. And I'm very sure that under the question that is gonna you'll be given G. Alright, G is another information that is constant. Alright, G is 10 meters per second, so already you know that. Then another information that is also you should know that is not given in this particular question is that this object actually is thrown vertically upward, right? It will reach the maximum height at that point. The final velocity is equal to 0. So please take note of that. Alright. So what we are being asked now to find for the A part of the question is the time for it to reach the maximum height. I call that small letter t. So now looking at this u, g, v, and t, which of this equation of motion under gravity actually captures that? And you can see that is the very first equation, right? So we've used the first equation, v is equal to u. Alright, then the question also asks which one are we going to use, minus or plus? Of course I'll use minus because g is negative, is upward. Alright, so minus gt. Alright, so we're looking for the time, so I put the value of the parameters. V is 0, u is 4, minus g is 10t. Alright, so rearranging this equation, I have that 10t is equal to 4. So invariably now my t is going to be equal to 4 divided by 10, which is 0.4 seconds. So this object reaches its maximum height at 0.4 seconds. That's number one question. The second question is time of flight. How do we get time of flight? Now remember, this object doesn't reach the maximum height and remain there. It will still have to come down. So the time, small letter t, is the time to reach the maximum height. At the same time, it will move from the maximum height within that same interval of time, up, forth, and backward. So the time of flight, this is a part of the question, right? So for the time of flight of the object, it's 2 times, because time of flight is just the total time. The total time it takes for it to get to this maximum height and return back. So that means if I should draw the graph of the motion, of course the motion is in 2 parts, up and down, right? So capital letter T is equal to 2 times small letter t, right? So that's of course the B part of the question. Alright, the B part of the question. So which is going to be equal to 2 times 0.4. Alright, so that's 0.8 seconds. Then finally we are being asked to find the maximum height. So I have an unknown parameter now, which of course is the maximum height. So which question now helps me with the maximum height? Which equation? Now you discover that the equation that will help me with the maximum height, alright, based on the prevailing parameters, owing to the fact that I know my u, right, and of course I know my t, so that will be the second equation. So that's gonna be h equal to ut, then of course you know it's going upward, minus half gt squared. Alright, so with what we have, h is going to be equal to u Of course, you know what u is. By u is 4, right? Multiply by t, which is 0.4. Then minus half times 10. Alright? Times 0.4 square. Alright, let's flow. Okay, I guess calculator will help me here, huh? I get a calculator. Okay, so let's calculate. 0.4 times 4, 1.6. Minus half of 10 is 5. Alright, then 0.4 times square. 0.4 square, 4 square, 0.16 times 10, 1.6. Alright, then of course divided by 2. So 0.8. This is 0.8. So we have 0.8 meter. So I hope that is well understood. Okay, please take note of that as we look at another question. Alright, example, this one is downward. An object is released vertically downward from a height of 20 meters. At what point, at what time will it reach the ground? At what time will it reach the ground? Alright, so solution. So we're looking at downward free fall from a height, right? This object goes to a height, and of course it falls from a height, and of course the height according to the question is 20 meters, right? Alright, so let's write our parameters. Remember, from a height where this object is being projected from, the initial velocity is equal to 0, so please take note of that. Alright, our g still remains a parameter we should not ignore. In as much as motion under gravity is concerned, g cannot be ignored. Alright, and of course h is 20 meters, right? Then what do we have? We are looking for the time to reach the ground. So which equation carries this, and this? That is the second equation, right? H is equal to ut. Then what am I using, plus or minus? This time I'm using plus, downward, right? For gravity. H is equal to ut plus half gt square. So h is 20, right? I write that down. 20 equal to u0 times the time, that's what I'm looking for, plus half times 10, which is the g, right? That times t squared. This is 0, is gone, so I'm left with 20 equal to 10 divided by 2, that's 5, 5t squared. Alright, with what I have, t squared is going to be equal to 20 divided by 5. So t squared is equal to 20 all over 5 is 4. Are we good? Then, of course, for me to get the t, that t becomes the square root of 4. So 2 seconds. I hope that is well understood, right? So please take note of how to use the equation of motion under gravity. Alright, so let's now extend it to the last part of our equation, alright? That is for a projectile. Alright, now for the projectile, I think I'm gonna illustrate that of a projectile, okay, by defining what a projectile is. Okay, I have to define what a projectile is. Alright, now a projectile is the motion of an object under gravity that actually follows a parabolic path. It goes like this. It's like throwing a javelin, right? Throws a javelin, goes up in the angular path for the point of projection to the point it hits the ground, right? Javelin, shot put, alright, even missiles, right, actually follows this projectile motion path. Alright, so we are going to discuss more of projectile and its parameters, right, in the next video. See you in the next video. Thank you.